Had you ever noticed something strange about your kitchen? You have this big, metal box on your counter. You put a slice of yesterday's pizza inside, press a button, and 2 minutes later, you pull out a soggy, floppy mess. The cheese is hot, sure, but the crust feels like a wet sponge. Now, imagine you take that same slice of pizza and put it into a different-looking box, one that your friend calls a convection oven. In 10 minutes, that pizza comes out with a crust so crispy you can hear the crunch from across the room. Both boxes use electricity. Both have a door and a timer. So, why is the result so different? Is a solo microwave just a weaker version of a convection oven? Or are they doing something completely different on a molecular level? Hi, I'm Sal. Today, we are going to dive deep into the science of heat. We are going to look at magnetrons, high-speed fans, and the secret chemistry of browning. By the end of this video, you will know exactly which machine you need, and more importantly, why your microwave keeps making your bread feel like rubber. Let's explain. Let's start with the solo. In the appliance world, the word solo means it is a specialist. It does one thing, and it does it using one specific type of technology, microwaves. Now, don't let the name fool you. Microwaves aren't just tiny waves. They are actually a form of electromagnetic radiation. They live on the same spectrum as the radio waves that bring music to your car and the light that allows you to see. Inside that solo box, there is a component called a magnetron. This is the heart of the machine. The magnetron takes the electricity from your wall and converts it into very short wavelength radio waves. These waves bounce off the metal walls of the oven like light bouncing off a mirror. But they don't bounce off your food. They go right through it. Here's where the real science happens. Most of the food we eat is full of water, and water molecules are very special. Scientists call them polar molecules. Think of a water molecule like a tiny microscopic magnet. It has a positive end and a negative end. When the microwaves pass through your food, they create an electromagnetic field that flips back and forth billions of times every single second. Because those water molecules are like little magnets, they try to align themselves with the field. So, they spin, they flip, they dance around frantically. Imagine a crowded room where every single person suddenly starts spinning around at top speed. What happens? People start bumping into each other. They rub against each other. This creates friction. And just like when you rub your hands together to stay warm, this molecular friction creates heat. This process is called dielectric heating. The heat isn't coming from the oven, it's being generated from inside the food itself. This is why a solo microwave is incredibly fast. You aren't waiting for heat to travel from the outside in. You are making the food heat itself up instantly. But there is a catch. Since the air inside the microwave stays cool and the microwaves only target water, the surface of your food never gets dry or hot enough to become crispy. This is why your pizza gets soggy. The water turns into steam, and since there is no hot air to evaporate that steam, it just soaks back into the crust. Now, let's talk about the convection oven. If a solo microwave is a molecular shaker, then a convection oven is a thermal wind machine. To understand convection, we first have to understand how a normal, old-fashioned oven works. In a traditional oven, you have a heating element at the top or bottom. It gets red hot and heats the air around it. That heat then slowly travels to your food. This is called radiant heat. But air is actually a very poor conductor of heat. It's lazy. When you put a cold tray of cookies into a regular oven, a thin layer of cold air actually wraps around the tray, acting like a protective blanket. This boundary layer slows down the cooking process. A convection oven solves this problem with one simple addition: a powerful fan and an exhaust system. When you turn on a convection oven, the heating element gets hot, just like a regular oven. But then, the fan kicks in. It blows that hot air at high speeds, circulating it all around the oven cavity. This does two amazing things for your cooking. First, it strips away that cold blanket of air I mentioned earlier. By constantly moving the air, the heat hits the food directly and continuously. Second, it creates a much more even temperature. In a regular oven, the top might be hotter than the bottom. In a convection oven, the fan makes sure every corner of the box is exactly the same temperature. But the real magic happens on the surface of your food. Because the air is hot, usually between 1080 and 250 degrees Celsius, it causes the moisture on the surface of your food to evaporate almost instantly. Once that moisture is gone, a famous chemical reaction begins. It's called the Maillard reaction, This is the reaction between amino acids and reducing sugars. It is what gives roasted meat its brown color, what gives bread its golden crust, and what gives fried food its delicious aroma. Without hot moving air, the Maillard reaction cannot happen effectively. This is why you can bake a beautiful golden brown cake in a convection oven, but you can only make a mug cake in a solo microwave. One is steaming the food, the other is chemically transforming the surface into a crispy masterpiece. Now, you might be thinking, Sal, I went to the store and I saw a machine that says it's a microwave oven, but it also says convection. What is that? That, my friends, is the hybrid. And this is where things get really interesting for your kitchen. A convection microwave is essentially a solo microwave that has a heating element and a fan tucked into the roof or the back of the machine. It is like having a tiny, high-tech lab and a professional bakery in one box. These machines usually have 3 modes. First, there is microwave mode. This works exactly like a solo. It uses the magnetron to heat up your coffee or defrost your frozen peas. It's fast, efficient, and uses less power. Second, there is convection mode. In this mode, the magnetron stays off. The heating element glows red, the fan spins, and the machine acts exactly like a small oven. You can bake cookies, roast chicken, or crisp up your fries. But the third mode is the secret weapon, combination mode, or Combi for short. In Combi mode, the machine uses both technologies at the same time. The microwaves penetrate deep into the food, cooking the inside at lightning speed. Meanwhile, the convection fan and heating element blast the outside, browning the skin and creating a crust. Imagine roasting a whole chicken. In a regular oven, it might take over an hour. In a convection microwave on Combi mode, you can get a juicy, perfectly browned chicken in about 35 minutes. You are using the speed of molecular friction and the power of thermal wind at the same time. It is the ultimate kitchen hack. Before you run out and buy one, we need to talk about the rules of science. Because these two machines work differently, they have very different rules about what you can put inside them. In a solo microwave, metal is the enemy. Remember how I said microwaves are like radio waves? Well, metal reflects these waves. If you put a metal fork in a solo microwave, the electrons in the metal start moving so fast they create a massive electrical charge. This leads to arcing, those scary blue sparks you see. Not only can this ruin your dinner, but it can actually bounce the waves back into the magnetron and destroy the machine. However, in a convection oven, metal is perfectly fine. We use metal baking trays and aluminum foil in ovens all the time because there are no microwaves to reflect. This is where people get into trouble with the hybrid machines. If you are using your convection microwave in oven mode, you can use a metal tray. But if you forget to change the setting and leave it on microwave or Combi mode, zap all, you just created a lightning storm in your kitchen. And the reverse is also true. Many plastic containers are microwave safe. This means they don't absorb microwaves, so they stay cool while the food gets hot. But if you put that microwave-safe plastic bowl into convection mode, the hot air will melt it into a puddle of goo in minutes. The lesson here? Always check your settings. The science only works if you follow the rules of the mode you are using. So, let's wrap this up. Which one should you choose? If you are a student, or if you mostly use your appliance to reheat leftovers, make popcorn, or defrost meat, the solo microwave is your winner. It is cheaper, it uses less electricity, and it is the king of speed for water-based foods. But if you love to cook, if you enjoy baking, or if you live in a small space where you don't have room for a full-sized oven, the convection microwave is worth the extra money. It gives you the flexibility to bake, roast, and grill, all while keeping the speed of a microwave when you're in a hurry. Think of it this way. The solo microwave is for heating. The convection oven is for cooking. The next time you pull a soggy slice of pizza out of a microwave, remember the science. Those water molecules were dancing, but the air was just standing still. I'm Sal, and now you know the science behind your kitchen. If this helped you understand your appliances a little better, don't forget to hit that subscribe button and give this video a thumbs up. It really helps the channel. Let me know in the comments, are you team solo or team convection? See you in the next explanation.